Hello, we're going to talk about recursion real quick, and that basically means that we have a method that calls itself. I want to start with the method of factorials. Now, if you don't know, factorials are numbers that do basically, if I do a factorial, let me kind of put up a calculator. I'm asking for like factorial of 6. I'm going to do like 6 times 5 times 4 times 3 times 2 times 1, and we're going to get 720. So if I do a factorial of 5, it's 5 times 4 times 3 times 2 times 1, and you get 120. If I do a factorial of 3, it's 3 times 2 times 1, and I get 6. So that's kind of how factorials work. It's a recursive concept in statistical analysis, and so if I do like 7, it's going to look like, see how quickly that this ramps up. So in a recursive function, I'm just going to call factorial numbers, for example, and then inside the method, it's going to call itself. But it's going to call itself with one less number than I passed in. So instead of 6, it's going to be 6 minus 1, which is 5. And it's going to keep calling it until it gets down to 0, at which point it's going to return, or in this case 1, at which point it's going to return 1, and it's going to cease the function. Right? So I have a call to that method. Let me start here, and I'm going to comment out everything else below this for now. Right. So I have that calling here, and I'm just going to simply call this program, and it's going to run factorials. And I'll just do 5, and you can see that it calls 5 first. So I have the method printing out the number. It's calling 5 first, and then 4, and then 3, and then 2, and then 1, and then it prints out 120. And I'll go ahead and make this for debugging. Right. And we will run this one more time so you can see how this method looks when we have it finished. Alright, so what happens is, just to clarify this one more time, every time it passes in the number minus 1, it multiplies the number that's returned by that value. So it continues to multiply it until it gets to the base case. If we were, the base case is the case we've set up in this conditional statement to ensure that it doesn't continue to run this infinitely. Without a base case, recursion is fairly meaningless. So this function works because it continues to call itself with one less number until it reaches 1, and then it returns that number of 1. It doesn't call itself anymore, and the recursive function is over. So that's how the factorial function works. I will, at this point, comment out the factorial method, and we'll talk about some other methods. So let's talk about mystery 1 that we've created here. Mystery 1, we'll pass in a value, and I went ahead and print out n for this one as well so you can see that value. Let's go ahead and call it. Right? And we're calling that now by passing in 5. Right? So I'm going to go ahead and call this. You see we got let me do one more thing here to make this work. So you can see the method. Working. Okay, we'll do that same thing for mystery 2. You need to know where the method starts, where it ends. Or we can target one method. We'll do that as well. Let's do this real quick. Mystery 2 and then 4, 3, so you guys can see exactly what's happening. And what I'll do is I'll comment everything else out down here. We'll work on those as we get to them. Okay, so let's save this and let's look at mystery 1. Okay, so mystery 1, we got 5, 4, 3, 2, 1, 0, 32. So what's mystery 1 actually doing? Well, let's look at mystery 1 now. Alright, so I'm going to go ahead and pull up like a notepad here and talk about what the values are every time we call it. Okay. So here's my notepad, and we're sticking with one value, right? So it's fairly straightforward. We have a value called n, right? So we have the n value, right? And when we start the n value, we pass in a 5. If it's not equal, if it is equal to 0, we return 1, else we return 2 times mystery 1. So it's going to be 2 times mystery 1, but now it's going to be 4, right? So mystery 1 at 5 is equal to this. Well, we don't know mystery 1 at 4 yet, so we need to know the value of mystery 1 at 4. So I put that in and I say, okay, this is also not equal to 0, so it's 2 times mystery 1 at 3. Let's not call that misery. 2 times mystery 1 at 3, and you can kind of see the pattern. I continue to do this, so we have a 3. I'm going to be 2 times mystery 1 at 2. When we have a 2, I'm going to be 2 times mystery 1 at 1. When we have a 1, I'm going to have 2 times mystery 1 at 0. And finally, mystery 1 at 0 returns 1. So now that I have 1, I can come here and say this is equal to 2 times 1, which is equal to 2. And this is equal to 2 times 2, which is equal to 4. This is 2 times 4, which is equal to 8. And perhaps you can see the pattern now. This is 2 times 8, which is equal to 16. This is 2 times 16, which is equal to 32. Okay, and that's what it finally returns. It returns 32. So you can see it calls it all the way down to 0, and then finally pushes back that 32 as the final return. So this function, if we were to name mystery 1, would be 2 to the power of, powers of 2 for mystery 1. Okay, cool. So let's go ahead and just name this mystery 1, and we'll go with that. Now let's look at the next one. Right, so hopefully this makes sense with this mystery. Alright, and then we're going to look at the next one. So we're going to go ahead and comment out this. We'll uncomment out mystery 2, and we'll look at what mystery 2 does. Alright, and I'll go ahead and run this, or save this, and run this function here. Alright. So now we have mystery 2, 4, 3 equals 81. This is a little more complex because mystery 2 is passing in 2 values. And because it's passing in 2 values, it's doing something differently. Sorry about that, I had a headphone issue. But because it's passing in 2 values, it's doing something differently. And we're evaluating right now the values of, and if you look at the header, we have n and a. So we have a value called n and a value called a. And we're going to start with n being equal to 4. So I'll just go ahead. Let's see, we'll have this. I'll do that. I will do this thing here, and we will have an A column. So hopefully this looks nice and pretty, kind of. Alright, so in the first pass, n is equal to 4, and A is equal to 3. Alright, let's get down to n 4 and 3, to mystery 2. So if n equals 1, then return A. Otherwise, return A times mystery 1, times mystery 2 n minus 1A. Right? So now I need to know this when I pass this in, because n is 4, I'm going to need to know mystery 2, 3, comma, A, which is 3. Right? So now I can pretty much copy this down, and we see now we have 3 and 3, but I need to find out the value for 2 and 3. Okay. And for mystery 1, for mystery 2 again, I need to find the value of 1 and 3. Well, now we know that that this returns, right? We need this value, so when we get to mystery 2, 1 and 3, actually let me see, I need A times 4. Let me just do this right so you can see exactly what we're doing. This is what we're pushing in. This is what we need to know the value of in order to get this done right. So mystery 2 and 3 returns the value of mystery 1 and 3. Right. Well, mystery 1 and 3 gives us a different value, so let's go ahead and jump that in real quick. Here's mystery 1 and 3, and mystery 2, 1 and 3 actually gives us A. Okay, now we have a value we can use. So I can come up here and say, okay, so now I have 3 times 3. Okay, and that's going to equal, of course, 9. And here, we're going to have 3 times 9, which is going to equal 27. And here we have 3 times 27, which is going to give me the value of 81. Right? So this is how this function works. And to some level, if you were to find out what this function is actually doing, I can pull up my calculator and say this is 3 times 3 times 3 times 3. 3 to the 4th power. So we're actually finding the same thing as before, except we're using it with powers of 3. So I can say this function is effectively pulling in powers of 4, powers of 3. Sorry. All right. Let's go on to the next function, and we're going to talk about what it does. Okay, so this is bunny ears, and I have several passes to bunny ears, and I will pull them out right now. So our bunny ears method. So a couple of passes we can see pretty quickly. The first pass, I have bunny ears at 0. And let's jump down to bunny ears, and you can see that if bunny ears equals 0, return 0. And then I have another method that says if bunny ears equals 1, return 1. And then I have this 2 plus bunny ears, bunnies minus 1. So let's kind of see what I'm calling. I'm calling 0 and 1. So we should expect to see 0 and then 2. And then we'll talk about what happens with bunny ears 5. But we're going to keep it pretty simple with bunny ears this time. And I'm going to go ahead and run this. And you can see I've got 0 and 2 and then I got 10. But what's happening? Well, what happens is bunny ears 5 returns 2 plus bunny ears 4. bunny ears 4 returns 2 plus bunny ears 3. Bunny ears 3 returns 2 plus bunny ears 2. Bunny ears 2 returns 2 plus bunny ears 1, and of course bunny ears 1 finally returns 2, so we end up duplicating it every time until we get to 10. So when we pass in 5, we effectively have 5 times 2 for bunny ears, and that's how the bunny ears method functions. Okay, let's jump into our final couple of methods. One is mystery 3. Mystery 3 is cool because this is when we start talking about call stack tracing. Because this particular method for mystery 3, it hangs out in memory until the method is done. So if I could, I can kind of show that real quick. Let me do it this way. I'm going to show, why did that happen? Because I deleted a bracket. Why is the bracket even up there? Interesting. Okay. So we're just going to say this so y'all can see this. Call to X. Initiated call to X, and well, so like this. Okay, and then at the bottom of the method we're just going to say terminated call to. So we're going to put the same thing, and we're just going to say terminated call to. Alright, okay, so we'll do it like this. Alright, so okay. So when I run this method now, you're going to see when the call starts and when it terminates. Okay, so we'll go ahead and run that particular method, or that function I should say, and we'll see what happens. Alright. So we've opened that up. We're passing in 1, 2, 3, 4, 5. Ooh, you know what else would help? Side note. End line, because it's going to be very confusing looking stuff if I don't do that. Alright. Okay, let's run this and see what happens. Well, nothing happened because I didn't actually uncomment out the call to the function. So that would be cool. Alright, so let's do that, and let's compile that again, and let's run. Okay, so you can see what happens now. I initiate a call to 1, 2, 3, 4, 5 at 5, and then I do it at 4, and then I do it at 3. What's actually happening is every time I call this method, if you see what goes on in the method, right? Every time I call mystery 3, it's going to pass in x divided by 10. This is integer division, so it's dropping out that value, so it's just returning out the digits above, right? If that makes sense. So what happens now is, let me go ahead and put an inline here as well, just so you can see this a little better, right? So what's happening is I can't terminate the call until this last thing is run inside this method. So you can see here, this needs to run. There's no returns in this function. It's a void method. There's no returns. So this needs to run before the call terminates. So the initial call to 1, 2, 3, 4, 5 stays in memory until it gets a return from the call to 1, 2, 3, 4. It just hangs out there. Same thing with 1, 2, 3, 4. Same thing with 1, 2, 3. Same thing with 1, 2. When it gets to 1, when I call that in, x divided by 1 divided by 10 is 0. Now I have an actual, I don't have to do this if condition anymore. it goes down and terminates the call. Now that I have a return that makes sense, or I basically not a return, but now that I stop the method from running, it can do the rest of it. It can go up and do the other things. So I need to terminate the call throughout the stack. So you can see this stack trace here, and that's what's happening when we run this method. It returns, or it prints, I should say. It prints out 5, 4, 3, 2, 1, and then 1, 2, 3, 4, 5, because the call to that method sits out in memory. Let's look at another method, and that method is mystery 4. Mystery 4, we're calling an XYZ XY XYZ XY XY. Okay, and what the method is doing is it's saying that if the first letter is Y, then return 1 plus next thing. So effectively, this is only going to return 1 when Y is at the beginning of the string. So when the string is reduces every time we run it, because we're effectively taking off the front every time we run this by saying 1 comma string length. It might help us here, if you want to see this, to print out what we're doing. Hold on. Cute. Come on. Why are you doing that? Okay, coot. str. Has caps locks on. Str. There we go. Alright, so it'll help us to see the string calls, to see what's happening until we get our return. So let's go ahead and run this now. And you can see what happens. So what does happen? Right? Well, it prints out 2. It basically adds 1 every time it finds a Y. So the question might be, why doesn't it add 1 the last call? And the answer is pretty simple. The last call is a call for Y, and the string length equals 1 at that point, so it returns 0 and never adds that last value of Y. So hopefully this makes sense. I'm going to go ahead and put this particular set of code on Blackboard so you have access to it, and we